Good afternoon, everyone. My name is Christian Allinson. I'm an automation, asset integrity, and reliability engineer from Chevron San Joaquin Valley Business Unit. So what I want to share with you today is some of the very local projects we've done in the cybersecurity space that we're looking at the equipment we have in our infrastructure, very, very native to SJV, and what we can do to improve our cybersecurity posture. So PCN Defense in Depth is kind of the driving topic of our cybersecurity program. Chevron Corporation. Chevron is one of the world's leading integrated energy companies. Through our subsidiaries worldwide, we operate in virtually every facet of the oil business, energy business, including exploring for, producing, transporting oil and natural gas, refining and distributing chemicals and lubricants, manufacturing and selling petrochemicals, generating electricity, and developing and deploying technologies. And Chevron is based in San Ramon, California. So welcome to the Bakersfield section. We are also in the San Joaquin Valley San Joaquin Valley. We operate in 6 fields throughout the Central Valley. We produce about 142,000 barrels of oil equivalent per day. We have multiple oil producing, gauging, treating, and shipping facilities, and this all has a very high level of automation. We have automatic well testers or gauging sites, distributed steam generation, cogeneration facilities, oil cleaning plants, and water cleaning plants. Our field automation is very geographically diverse, but critical components are highly localized. So by this, I mean that our facilities can really run independently from each other. So everything you need automation-wise is really at the site. What this really means is we have a lot of stuff. Our PCN inventory, we have over 700 computers in our PCN environment, over 300 HMIs, about 800 field-mounted operator interface terminals, somewhere approaching 3,000 programmable logic controllers, and over 300,000 end devices. So we have a lot of stuff to keep safe. And the theme for all of it is PCN Defense in Depth. So this isn't really new to anyone that's been at the sessions this week. PCN networks, particularly ones that are diverse, either geographically or the technologies you employ, can be susceptible to different attacks. So by applying various measures at different levels, you can reduce the likelihood or the impact of a successful cyber attack. So different themes for these types of controls, physical, technical, administrative, it's all coming down to each piece you secure is overall improving the posture of the security of your network. So for us, cybersecurity isn't new to SJV. This is a few successful projects we've done in the past. We've done an effort to separate out our corporate and PCN traffic from our interfield WAN. We've done the separation and encryption of that. We've split up our enterprise and PCN data center, our compute and storage space into 2 different facilities. We have a PCN-specific Active Directory domain, so we've migrated all of our assets off of our corporate AD and put it on a PCN-specific Active Directory. Automation program control, we have a centralized system that manages all of the programs for all of our automation assets. If it's an HMI, a PLC, or whatever, we have it in version control that can automatically look and tell us if what's running in the field doesn't jive with what's in version control, and it also gives us a really good disaster recovery option as well. We have constant improvements in our safety instrumented system, segregating out our SIS from our normal BPCS systems and improving the security of those more critical safety systems. And we have a very mature asset lifecycle management system. So we have a program where we look at the automation assets in our field. We have specific plans on how to upgrade, update, and apply patches to them as necessary. So we're always looking at continuous cybersecurity improvement. This really comes from our very active cybersecurity research plan, and this is driven by our cybersecurity management shaping plan. We have about a 3 to 4 year shaping plan with various technologies and topics that we're interested in looking at for the next few years. A strategy for taking all of these topics through the lab testing phase, conceptual pilots, aligning with operations, and aligning with IT and maintenance, and then finally doing the field deployment and turnover. This is carried as a multi-year business unit initiative, so this isn't something that we kind of start and stop. This is something that's continued. And what I want to share with you today is a few of the more interesting topics that we've looked at over the last few years that have come out of the cybersecurity shaping plan. And these are unidirectional gateways, two-factor authentication, and then application whitelisting. So the first one is unidirectional gateways. You may better know this as data diodes. The concept of a unidirectional gateway is that it's a device that physically can really only allow data to go one way. So on your secure side, you have something like a send-only circuit like an LED. On the unsecure side, you have a receive-only circuit like an opto-isolator. So the idea is that, unlike a normal firewall, there's no way to misconfigure this device to allow data to go from the unsecure side to the secure side. We've had a lot of good partnership with Al Cyber Defense in doing this work. And we're continually evaluating products for two general use cases. One is for Windows kind of systems, and one is for automation kind of systems. For Windows stuff, we get the idea of Windows events, antivirus alerts, host inventory, all the stuff that we might be collecting from systems that are on our normal network. We want to get the same thing from systems that are isolated. And then for the automation side, we have a lot of third-party connections, either through the companies that we sell our product to, or the electrical utility, Cal ISO, things like that, where we want to have control over the data. We only want our data going out. We don't want anything coming back in. So on IT protocols, to give you an example of a use case we've looked at, something if you have an air-gapped SCADA monitoring system. To make sure that this system is secure and up to date, we want to get Windows events. You might want to get application events from the SCADA system that's running, antivirus alerts and stuff like that. And if you were to have a conventional air-gapped system, you would either not get those, or it would be a manual process. Someone would have to go and visit, collect those logs. If you are like us and have a very robust log ingestion system, then you have to manually load it and all that fun stuff. So using a data diode is a very attractive option. You're maintaining that same isolation as you would with an air-gapped system, but now you can get these logs streaming across, and the system starts to look a lot more like anything else that's in your inventory. So in all of this, we're trying to find sustainable architectures and sustainable solutions. It doesn't really help us if the application we find in the device that we decide to use is really, really hard to implement and to manage. It's not going to become popular with the people that have to manage it, and that's just giving us more risk of it being misused. What we find in a lot of things is for like our log ingestion system, some of these platforms might have what they call data diode add-ons, but these seem to typically involve added complexity on the secure side. So we try to stay away from that. One of the better things we've looked at is kind of a catch-all with syslog. We can get syslog agents that will capture all the logs and all the stuff that we're interested in. That's a protocol that's supported by a lot of diode vendors. So it doesn't look so different getting this information across than once it comes out on the other side is syslog information. Another system will break it out and put it into whatever we're ingesting it with. So we're continually developing this space. We try to look for other applications where we have an isolated Windows system. We continue to work with our vendors like Al to better improve. So a lot of things have some commonality. Windows systems, it's always going to be Windows logs and antivirus logs. But depending on the application, we might have a different kind of SCADA system or a different type of engineering software, each with its own kind of logs that we want to get out. So we work with our vendors to make sure that we can get increased support for these file types that might be interesting to us in SJV. And on the automation side, we look a lot at Modbus. Conventionally, that's been I'd say maybe the preferred way to get third-party data from your automation system to someone else's. So we look at better ways to do Modbus data flowing from us to them, and we also are looking a lot at SIP. Really for the same reasons, we have third-party connections, but SIP is a more modern protocol, so we're trying to get the same support and the same supportability for those kind of data streams. The second is two-factor authentication. So two-factor authentication is this concept of something you have and something you know. In Chevron, we have this very well integrated in our corporate environment. We call it a smart badge. It's really just a smart card that was what we use for access to all of our business systems. And this becomes very attractive because a lot of automation vendors are starting to support smart card functionality. We already have a robust infrastructure and already have this deployed in our business. So it's attractive to us to use the smart badge and integrate it into some of our automation platforms. And since we have our own Active Directory domain that supports our smart cards, it's even better. So 2 research areas we've looked at are control room HMIs as well as field-mounted remote terminals for places where you can put in two-factor authentication with smart badges. The first one is control room HMIs, and I can generally break these use cases down into 2 different things. One is action auditing, and the other is action approval. So in the instance of action auditing, there may be set points or stuff like that, mode changes that for some reason operations wants to know who made the change. And through various means, and maybe shift schedules and looking at historical data can give you an idea of who made the change, but it's not that definitive. So by putting in something like two-factor authentication, we can have something kind of signed saying this was the person that made the change. And the section is action approval. So you may have instances where there's a set point or a mode or something that can be modified from the HMI, but it's not something you want to give your normal board operator access to. So action approval is having someone a little bit higher, like a head operator, your production tech, or OS, have to approve a change, and then both of those, the nominator and the approver are logged as well. So to give an example, we've tested this out at one of our manned treating facilities. We've tried both action auditing and action approval. For action auditing, this is a water cleaning plant, so we have some water treating machinery that has some batch processes for regeneration. The rate and time steps for those batch processes are usually tuned by the process engineer, and it's not something that the operator should normally have to change. But if they do, it can have usually negative economic effects. It's not as efficient of a process if operators are tweaking those parameters in the middle of the night. So action auditing helps kind of keep a record of who's doing what. It lets the OS know who made the change, if a change was even made, and it helps them track it back to find the person who did it, and they can validate that it was actually beneficial and not just them playing with it. And the other is action approval. So in this instance, we had some PID controllers that the set points really shouldn't be changed. So if the operator wanted to change that set point, it required the approval for someone like their head operator or their production tech to approve that change. And again, that's all logged and recorded. So our methodology, a lot of HMI packages we use have some sort of built-in features for action auditing and action approval. And action auditing is kind of the one person approves. Action approval is kind of 2 people are approving it simultaneously. What we found is that where we want to do action approval, the built-in solutions from our vendors weren't really meeting our needs. It seemed to be a lot of 2 people kind of turning their keys at once, and that doesn't really work for us if we want to do a remote approval. So we kind of implemented our own thing. We're doing really the one approver action auditing thing, developing our own security model so that we can make it really customizable for us and split out the security of who's allowed to change what in different areas. We can do remote authentication and things like that. Some of the challenges we had were that we have our own HMI template that we've developed, and changing to two-factor authentication changes the security model for that software, which broke some stuff. So we've been working to improve our base template so that as we are deploying this wider, everything will run as it should. And the other thing is remote approval. So if we want to have remote approval from like a terminal server, this is changing where we have previously had our architecture where the terminal server is supposed to be read-only. It's just supposed to give you information about the plant. You're not supposed to be able to do anything. So both our architecture and licensing prevents that. We need to come up with some better ideas to do remote approval so that you don't have to have someone actually physically in the control room to approve a change, because that, for us, with a very geographically dispersed location or diverse location, we have OSs that cover plants that are, could be 100 miles apart. If they're in one and need to approve an action for another, it's not always convenient or even practical for them to travel there. Go. And again, continuous improvement. We're trying to integrate this better into our HMI standard, improving our options for remote approval. Of course, the OSs want to be able to approve it from their cell phone, so we're looking at something for that. And then our break glass option. So this is an HMI. This is the operator's interface to their control system. If something does go wrong, their smart card doesn't work or Active Directory decides it doesn't want to play that day, we need a break glass option so that we can keep control of the facility. And then the widespread implementation, there's a lot of things that are common to all of our facilities, like alarm suppression, where it turns off the horn for an alarm for a little while. That's a common thing for all our facilities. We want to be able to audit who suppressed an alarm and for how long. Some things are a little bit more bespoke. If you take the example I had before of a certain piece of water treating equipment with these rates and set points that can be changed from an HMI, that may not be implemented in the same way in a different facility in that field. So we can't really put a blanket rule over this is how we're going to implement two-factor authentication for everyone, because it's just not going to work out. And the other area we're looking at is remote terminals. So we typically use only one type of remote terminal. We conventionally call them OITs. So we have a high level of standardization, so we can kind of get one solution and apply it everywhere. Our OITs are mounted outdoors, and that can present a challenge to physical security that you don't really have for a manned control room or a fenced-in facility. But the benefit of these terminals is that they have an underlying operating system that can support some general computing functions like talking to Active Directory, and then also a programming interface so that we can pass information from that underlying operating system or run programs and pass it back into the kind of the HMI environment. So we're looking at two different ways of implementing two-factor authentication, really more for just logging in users. One is using the smart badge and PIN through Active Directory like we did with the HMI before. And the other is visiting some RFID login techniques that the vendor recommends. So the first one is really interesting, the smart badge and PIN. We can connect a USB smart card reader to our terminal, and we're working with the technology vendor that did all the smart badge applications on our business side for Chevron to help us develop a custom application that we can run on these terminals that will read the certificate, decrypt it with a PIN, check the user against Active Directory, and return the information we need to see if that user is currently active and if they're in a group that would allow them to log into that terminal. And then all this would be wrapped up in an ActiveX thing that would pass this information back and forth to the HMI or to the OIT. And then we have to kind of rebuild the security model, since the application we use doesn't really allow you to programmatically log in or log out users into the same security model it uses normally. So this is really interesting research for us. We're doing some kind of novel things and using technology that we have in the business network, bring it back into automation so that we can reduce the number of different credential systems we have to manage, and we get the same benefit out of both. And this is a little example of how it works. You put your smart card in, it gets your certificate off of it, you put your PIN in, it decrypts it. That information is passed from the wrapper down to the little application that's being developed. That decrypts it, checks it against Active Directory, which returns, can that user log in or not? If they can, they log in. If they can't, they don't. RFID login is supported by some vendors. It's an RFID card and an RFID reader. It really acts like a keyboard. You touch the card to the reader, it pops a string in and it logs you in. Since a lot of these parameters on an RFID card can't be changed over time, we don't really consider it a true two-factor authentication. But we're really reviewing this more as a comparison point to something that the vendors already recommended and is supported by them, versus what we're doing with the smart card, where we're kind of blazing our own trail. And finally, application whitelisting. So application whitelisting is technologies that work kind of inversely to antivirus or a blacklist. So rather than blocking known bad applications, you only allow known good applications to run. So we're working in application whitelisting. We're comparing several vendors. We're really trying to find the best mix of, ease of deployment. We have a very mature Windows server environment. So we use SCCM and a lot of other techniques. So anything we can do that we can deploy and manage it through those similar tools we like. So we're looking for things that work with Windows, work with group policy objects for ease of administration and deployment. And what we're looking at is places where whitelisting can really protect the most critical assets for us in the PCN space. So that's really what do we have to run the plant, and that's generally the IO server and the HMI. So we're looking at applying application whitelisting to those preferentially, and then looking at the other servers in the PCN space and securing those with whitelisting techniques as well. So an example, and again, another manned control room. We've been successful in building whitelists that work on our HMI software. We can deploy and enforce whitelists on I/O servers and HMIs. We've been able to monitor for blocked events, either it's real or for testing. We have notifications so that the server team knows when something like that happens. And we've been able to successfully do this while still going through our normal processes for patching and maintaining our systems, which are very regular for us. So all in all, it's been an overall success. We haven't had any issues with our HMI software. We've been able to apply a whitelist and still maintain our systems the way we were before. So our future whitelists we're coming up with better techniques. We have active asset lifecycle management plans. So as we upgrade our softwares and upgrade our servers, we want to make sure that we're taking that opportunity to push out whitelists with them. So everything new that goes into the field is kind of inherently secured with this technology. And in summary, so we have a long history of successful pilots and projects in SJV around cybersecurity. Defense in depth is a really important strategy. It doesn't make a lot of sense to just focus on one area and try to secure it the best you can. You need to look at every level, or all the layers available for an attack and work to secure those separately. And I think the biggest takeaway for this program is that technology is often not the most important part. So we have the fun job in automation that we cover engineering, maintenance, and IT. So if we're pushing out a technology or solution that we as engineering think is great, we have to be able to make it work with maintenance's plans, and IT has to be able to operate with it as well with their systems. So open communication, firm expectations are all critical to project success. And with that, I am done.